Particles 1 and 2 move with constant velocities v1 and v2 along two mutually perpendicular straight lines towards the intersection point O. At the point t equals 0, the particles were located at the distances L1 and L2 from the point O. How soon will the distance between the particles become the smallest? What is it equal to? This question is explained in this figure. The particles 1 and 2 are moving with velocities v1 and v2 along two mutually perpendicular straight lines towards the point O. Initial distances of the particle 1 is L1 and particle 2 is L2. And the question is to obtain the minimum distance between the two particles and the time when the distance becomes minimum. So let's assume that at time t the distance become minimum. Let's evaluate the distance. For this, first we evaluate the displacement of particle 1, which is minus L1 plus v1 t I cap, and displacement of particle 2, which will be minus L2 plus v2 t j cap. The displacement between the particles at time t will be minus L1 plus v1 t I cap minus L2 plus v2 t j cap. And distance, we know that distance is the modulus of displacement. So the distance will be d equals square root of L1 minus v1 t whole square plus minus L2 plus v2 t whole square. On simplification, we will get square root of L1 square plus L2 square plus v1 square plus v2 t square minus 2t v1 L1 plus v2 L2. The distance will be minimum when the function ft equals this function v1 square plus v2 square multiplied by t square minus 2t v1 L1 plus v2 L2 becomes minimum. For this function to become minimum, we need to satisfy the conditions that f prime t should be 0 and f double prime t should be greater than 0. So let's evaluate the first derivative f prime t of the function ft. So f prime t will be 2t multiplied by v1 square plus v2 square minus 2 times L1 v1 plus L2 v2. And if we equate this expression to 0, we will get the value of t as L1 v1 plus L2 v2 divided by v1 square plus v2 square. Now we need to verify whether the value at t equals L1 v1 plus L2 v2 divided by v1 square plus v2 square f double prime t is 0 or greater than 0 or less than 0. So we obtain the f double prime t as 2 times v1 square plus v2 square, which is greater than 0. So the value of t L1 v1 plus L2 v2 divided by v1 square plus v2 square corresponds to the minimum value of function ft, and we obtain the minimum value of function ft by putting the value of t equals L1 v1 plus L2 v2 divided by v1 square plus v2 square. The minimum value of ft is obtained as minus of L1 v1 plus L2 v2 whole square divided by v1 square plus v2 square. So the minimum value of distance will be d mean equals square root of L1 square plus L2 square minus L1 v1 plus L2 v2 whole square divided by v1 square plus v2 square. On simplification, we see that the numerator becomes a perfect square, and if we take the square root, we get modulus of L1 v2 minus L2 v1, and d mean becomes modulus of L1 v2 minus L2 v1 divided by square root of v1 square plus v2 square. Thank you for watching this video.